welcome back to Simplified Human Physiology for the ninth and 10th grades. I'm your teacher, Dave, and we will be continuing today. Now, there's little change in plans here. We have covered the first two modules. Module 1 was entitled Water, Water Everywhere, and it went over the various places where water was in our body, and it covered the skin. Module 2 was entitled Where Does the Food Go? And that was all about digestion. We are headed into the next module, which would be breathing and the lungs and bringing air into the body. But I think we're going to have a little detour here because it just occurred to me that there's a lot of metric units in the physiology field. And I think it would be very helpful if we reviewed the metric system at this point. I think I have a very, very clear presentation of the metric units that we will be using in physiology. And I hope you bear with me that this will be our third module. And then our fourth module, we will go into breathing and the lungs. Now, I'll give you an option. You can go through the metric review here, which is only about 12 or 15 minutes long. Or if you feel you already know enough about the metric system, you can zip on ahead to the next module, Module 4. I'll leave that up to you. But I would highly advise you to take a look at the review that I have prepared for you. Okay, with that in mind, we are going to go back in time a little bit, and we're going to go back to 1799, and we're going to France under Napoleon. And at the time, French scientists were kind of disappointed in how they were measuring things, and they decided to get a system of measurement that was much more accurate. Up until that time, what they had done is basically measure the king's foot. There was always a king, and when he came into power, someone would go measure his foot, and then that would be how long 1 foot is. And then throughout the king's realm, everybody would agree that that's what the measure is. The problem being that the king would eventually die, and then there would be a new king and a new foot, and everything had to change. So these scientists in France said, that's a ridiculous way to proceed with science. And they said, we need something to measure against that does not change. And what do you think that was that they came up with that does not change? Well, it's the Earth. And what they did, actually their mathematics was pretty good back in 1799. They were able to measure the Earth from the equator up to the North Pole. And they were quite accurate looking back on it now. And what they did was they came up with a number 6,200 miles. Again, from the equator up to the North Pole, about a quarter of the way around the Earth. Well, you can't measure anything with 6,200 miles, so they had to make it a smaller number. And so what they did, they played around with different numbers, and they finally divided that number by 10 million. Well, when they divided it by 10 million, they got 39.4 inches. And they said, hey, that's a pretty good length to measure different things. In fact, we can even make a stick that's 39.4 inches long, and we will call it a meter. And the stick we will call a meter stick. And that way we can carry this meter stick around with us and measure things. Oh boy, what a deal. So this was the beginning of the metric system. Everything was based on 39.4 inches, which was the meter. Now, what does a meter look like? Well, I can't put a meter on the table here, it's too long. But if we pretend that this line is a meter long, in other words 39.4 inches, then this line is a yard long, 36 inches. Now, everybody knows what a yard is, right? Like if you've gone to a football game, you know that the length of the field is 100 yards, right? Or if you play golf, you'll know that they will hit the golf ball, a couple hundred yards, all right? So comparing a yard to a meter is just a few inches longer than a yard. Okay? Now, when we measure length, it helps to have a smaller unit of length than the meter. Okay? For example, sometimes we want to measure things like a playing card, the length of a playing card, or we want to measure the length of a pencil, right? And a meter is simply too big. So let's take a meter and divide it by 100 parts, or into 100 parts, and each part is a centimeter. Each part is a centimeter, okay? Now, to give you an idea what a centimeter looks like, if you look at this square right here, it is 1 centimeter on each side. So that gives you an idea of why we could measure something like a playing card using the distance of a centimeter. Okay. By the way, centimeter is abbreviated lowercase cm. So again, if you take a meter, divide it into 100 parts, each part is a centimeter, and with a centimeter, you can measure things like the length of a pencil. Okay? But what if you want to measure things that are even smaller than a centimeter? Well, then you take a centimeter and divide it into 10 parts. All right? And when you divide it into 10 parts, each part is a millimeter. Now, I'm going to show you on this ruler here what a millimeter looks like. You see the distance? Let me turn it around so you can see it a little bit better. You see the distance from the 8 to the 9? That's a centimeter, okay? Now, you see that little division right there that I'm pointing to that just is like the tip of the pencil? That's a millimeter. It's pretty small. It's not microscopic, you can see it, but it is very small. There are 10 millimeters inside 1 centimeter. Okay? So what can we measure with a millimeter? Well, we could measure the diameter of a penny, for example, or we could measure the diameter of a lamp cord. All right, anything that's very skinny like that. We could also measure the diameter of the pencil in millimeters. Okay. All right. So again, take a centimeter, divide it into 10 parts, we get millimeters, which is always abbreviated lowercase mm. Now, what about area? In other words, flat space. How am I going to measure flat space in the metric system? Well, we have what's called the square centimeter. And I have a visual aid for you. This little thing I showed you before. Whoops, it got all crumped up here. There we go. That is a square centimeter. It's 1 centimeter on each side. And as you can see, we could use that unit to measure the area of a playing card, right? Or the area of a lid of a can, right? A square centimeter, a very, very common metric unit. And it's abbreviated lowercase cm to the second power. Okay? And like I said, you can measure things like a playing card or a sheet of paper. Now, you could also use a square meter to measure things. Remember, a meter is 39.4 inches long, but if you square that, then you would have like a picture that would be a meter long and a meter wide, right? What kinds of things could we measure using square meters? What kind of area? Well, you could measure the floor of a garage in square meters. If you wanted to paint the inside of your house, you could also measure the wall, the wall surface of your house, maybe in your bedroom, also in square meters. Because when you went to the paint store, you'd have to tell the paint guy how much paint you want, right? And he's going to say, well, what's the area that you're painting, see? And you could say so many square meters. Okay. Okay, now, besides area, sometimes we want to measure volume, which means the space inside something, like inside a box or inside a jar. Okay, that's called volume, all right? And what are we going to measure with? Well, let's take a cube right here that is 1 centimeter on each side, all right? Now, we call that a cubic centimeter because it's a centimeter on each side and it's a cube, and we abbreviate that centimeter to the third power, cm, lowercase cm to the third power, cubic centimeter. This is used a lot in physiology as a measure of volume, whether it be blood or air, spinal fluid, lots of different things measured in cubic centimeters. Okay? Now, where does the liter come from? If we take this cubic centimeter and we have 1,000 of them, 1,000 cubic centimeters, that's what a liter is. Okay, simple as that. A liter is also used a lot in physiology to measure air volume, volume of blood, and various other fluids. Okay. By the way, a cubic centimeter is sometimes abbreviated cc, cubic centimeter. And sometimes you will hear the phrase ml, meaning milliliter, which is my preference for volume. Well, it just so happens that a cubic centimeter is the same as a cc, is the same as an ml. So don't get confused there. Just different ways of saying the same thing. Okay, we're going to move toward weight now in the metric system. How do we weigh things in the metric system? And we're going to go back to that liter that we just had. All right, and we're going to fill a liter full of water. So you can imagine a liter of water here. Guess what it weighs? It weighs a kilogram. That's where the phrase kilogram comes from. And we abbreviate kilogram, small case kg. So again, a liter volume filled with water, the water weighs a kilogram. Now, what if we have a smaller measurement that we want to do? We want to maybe measure the weight of this pen here, all right? Well, kilograms is too big, right? Kilograms is used to measure the weight of a person or the weight of a table. But if you want to measure something like the weight of a pen or the weight of a pencil or the weight of a playing card, now let's use grams. How do we get grams? Well, we take a kilogram, divide it into 1,000 parts, and each part is a gram. In other words, it takes 1,000 grams to make a kilogram. And we abbreviate gram with a lowercase g. But what if we want to go even smaller? Okay. You well know that medications are often described in milligrams, so where does this come from? Well, if we take a gram and divide it into 1,000 parts, each part is a milligram. And we abbreviate that with a lowercase mg. Okay? All right, so those are the major metric units. I do want to cover something that we're going to run into when we talk about the lungs and air pressure. And I think you'll find this very interesting because these are the units that we measure air pressure and blood pressure in physiology. So it's very useful to know. We are going to go to this question: does air have weight? And this was a question that scientists in the 1600s were wondering about. They just didn't know. Until an Italian in about 1630 named Torricelli came along. Actually, he was a student of Galileo. And he was wondering if air had weight. And he did an experiment one day. And I'm going to go over that experiment with you because it's absolutely fascinating. Torricelli took a bowl and he filled it with mercury. All right? Mercury. Now, where did this Hg come from? That's the chemical symbol of mercury. And in Latin, the old language of Latin, mercury was called hierogyrum, which meant silver liquid or silvery water. And so here's the H and here's the G, hierogyrum. And they've kept that Hg to mean the chemical symbol of mercury. Okay? Getting back to Torricelli, he filled this bowl full of mercury, and then he took a glass tube, which was closed at the top, open at the bottom, and he filled it with mercury, all the way, completely filled with mercury. Then he turned it upside down so that the open end was pushed down into the bowl of mercury. Remember, this is all mercury here. And the closed part was up at the top here. This is a glass tube. When he did that, he noticed something very interesting, that the mercury came down in the tube and then stopped right here. Now, what question did Torricelli ask himself when he looked at the mercury stopped right here? What do you think he was wondering about? Well, he asked himself, why didn't all of this mercury flow back down into the bowl? Why did it stay up in the tube like this? Not only that, mercury is very heavy. It's 13 times heavier than water, which would make it even more likely to flow back down into the bowl by gravity. But Torricelli said, you know what? It must be holding this mercury up in the tube here. What could it be? And what do you think his answer was? Well, he said it must be that air is pressing down. The weight of the air is pressing down on the mercury in the bowl, which is pushing this mercury up in the tube. He said that's the only explanation that makes any sense. And when he measured the height of the mercury in the tube from the surface of the liquid up to where it was 760 millimeters high. In other words, from here to here, 760 millimeters, which, by the way, is the same as 76 centimeters. Now, he did this experiment at the beach, in other words, at sea level, okay? So his conclusion was, you know what, at sea level, the air pressure pushing down must be 760 millimeters of mercury. And that has become the unit of air pressure now. By the way, in doing this experiment, Torricelli invented a instrument that is used by weather scientists all the time. What do you think that instrument is? It's the barometer. The barometer, which, by the way, forecasts hurricanes and tornadoes. Now, we're almost finished here. Torricelli noticed something very interesting. At sea level, he saw that the mercury in the tube was 760 millimeters high. But then he took this whole apparatus and he went up in the mountains, about 5,000 feet in the mountains behind Rome, Italy. And what did he think he found when he set up this apparatus again? The mercury dropped in the tube down to 630 millimeters. What do you think that told Torricelli? Well, if less mercury was being held up in the tube, wouldn't that indicate that there was less air pushing down? And so Torricelli concluded that the higher you go, there's less air, and therefore there's less air pressure. And he was exactly right. And in our next module, when we get into air pressure and various altitudes that mountain climbers climb and that jet airplanes go, we're going to take a further look at Torricelli's work here. All right. And the last thing we're going to look at is that this unit called millimeters of mercury, in other words, how high in the tube the mercury went in millimeters, this has become the standard measurement for both lung pressure, air pressure in the lungs, and for blood pressure. And when we get to the units, to the modules about the lungs and about the blood vessels, we are going to be using this millimeters of mercury as our standard. Okay. Finally, in honor of Torricelli, when we say 1 millimeter of mercury, we can also call it 1 torr. 10 millimeters of mercury is 10 torr, and so on. In honor of Torricelli, each millimeter of mercury we can call a torr. And you frequently see that on blood pressure devices, and sometimes doctors and nurses will use this word torr also. So I hope you've enjoyed this review of the metric system and what Torricelli discovered about pressure. All of these will be used in future modules, and I hope this helps you along. If you find that some difficulty with what I've gone over, then please play the video a number of times, and I think you'll find that it'll sink in and make a lot of sense. The beautiful thing about the metric system is that everything is divisible by 10, or as a multiple of 10. It's kind of like our money system, and it just works beautifully. Once you go into the metric system and use it, you will never go back to the old English system, which is just not very accurate and very helpful. Okay, this is Dave signing off, and hopefully we will see you again in Module 4 about the lungs and breathing. Goodbye now.